Hello everyone. Today we'll tackle another problem from combinatorics and probability calculus. Let's read the exercise. There are 16 students participating in a school trip, among whom only 4 know the area. The teacher wants to randomly select 3 students to go to the store. Calculate the probability that exactly 2 students of the selected students will be those who know the area. So how to do it? First, let's write all the numbers we need. 16 students. These are students who participate in the trip. Okay, all the students. 16 is the total number of students. What is number 4? 4 is the students who know the area. So there are 16 students, but only 4 know the area. So we also write number 12. Why 12? Because 16 minus 4 is 12. So if 4 know the area, it means that 12 don't know the area. So we write 16 is total. Add 4 know the area. 12 don't know. 12 don't know. Always write like that when you do this kind of exercises. So all the numbers will be clear for you, and later you can set up calculations knowing this data. We also know that there's number 3. What is number 3? 3 is a selection out of 16. So a teacher will select randomly 3 students out of 16. And later we have only 2. 2 is 2 out of 3, because he wants that 2 will know. 2 will know from 3. 1 will not know. So as you can see here, they provide only 16, 4, 3, and 2. But we did additional calculation and we extracted more numbers. So thanks to these numbers, we will be able to use them in a calculation. So for this kind of exercise, we need to know also what is probability, because here they introduce the concept of probability. Probability, often written as omega, is a number of favorable events divided by total events. So we can write here favorable events, events in favor, which means that they tell us what we expect, so what we want. We need to calculate all the possible favorable events which meet the requirements, and it is a ratio of these favorable events to total events. So in here we will have to know how many favorable events we have. First we'll calculate it, later we'll calculate how many total events we have, and this ratio will mean the probability of that. And we also introduce a rule of multiplication here. We will need combinations. In the previous video I showed you what are combinations. Why combinations? Because order does not matter here. So if you choose Katie and Andrew, or Andrew and Katie, is the same. So order does not matter. Therefore, we need combinations to calculate it. Combinations, and formula from my previous video, you know that combinations is like that, is n factorial divided by k factorial times n minus k factorial. Here is in brackets because first we will subtract a bigger set from the smaller set, and we will factorial it. We will use a factorial, we'll multiply them. Okay, so we'll calculate this combination. So you need to know two kind of combinations, and I mean there will be, we will select two different combinations, or multiply them. There's also something called rule of multiplication. rule of multiplication. So first we use combination, later rule of multiplication, and later we will use probability theorem, which means that all the favorable events will be divided by total events. So first of all, calculate the favorable events using combinations. So what are favorable events? It's two students know the area, and we select, I mean, 4 students know the area today, but we select 2 students from, we select 2 from 4, because our target is 3. 3 students will go to the shop. 3 students go to the shop. 3 students go to the shop. But two from these 3 students will know. But we don't calculate 2 out of 3, not 2 from 3. We calculate 2 from 4, because we need to know in total how many favorable events are there possible. So don't do it 2 out of 4, 2 out of 3, but do 2 out of 4. So we need to write 2, 4 times, this is number 2, not 1. I wish I could have a better tool for writing on the digital screen. So we have 2, right? We have 2, and here we have times, 2 out of 4. Later this what you see in brackets will be transformed into this combination formula. But first we write how many? 2 out of 4 times 1 from 12. So why do we write it like that? Why do we write 2 from 4? Because 2 are selected in a 3 random students, and 4 is total students knowing the area. That's why it's 2 from 4, and we need to multiply it, because we also choose 1 student who doesn't know the surrounding, 1 out of 3, but later this 1 student is selected from 12, because 12 students, as we hear, 12 students don't know the area, so it has to be 1 from 12, not 1 from 3, but 1 from 12. Okay, and now you need to use the formula for combination to calculate separately this and that, and later multiply them together. And then you will know the total favorable events which are satisfying your request. Okay, so let's calculate it. We will substitute n and k with these values which we have here. So here I am. So we write n factorial. N factorial is this bigger set. So we write 4 factorial, which is 4 on top. Here we write k factorial. K factorial is the smaller set. So we write 2 factorial times 4 minus 2, because it's n minus k factorial. So how much is it? You will have 4 factorial divided by 2. 2 factorial equals 2 times 2 factorial. So 2 times 2. So divided by 4. But you can make it even easier. You can just simplify, cancel out this 2 factorial with that one. So what you will have left is 3 times 4 divided by 2. So 3 times 4 divided by 2, 12. 12 divided by 2 equals 6. One more time, look at this. 4 factorial and 2 factorial. You can simplify it. So you have 3 times 4, because it's 1. It's like this: 1 times 2 times 3 times 4. And there you write 1 times 2. So this 1 times 2 will cancel out, and you have only 3 times 4, which is 12. And here you have again 2 factorial. 2 factorial is 1 times 2 is 2. So 12 divided by 2 is 6. Okay. So this 2 out of 4 equals 6. And this one will be 12 because you have only one number. So if you multiply 1 out of 12 will be 12. So what we get here, so as this part 2 out of 4, we have 6 times 12. So it equals how much? 72. So what you see here, total amount of favorable events is 72. So instead of writing favorable here, we can write on top, we can write 72. So these are total possible selections satisfying our need, but it's not probability yet. Probability is this ratio of favorable events to total events. So now we need to calculate what are the total events. So we have 60 students and we select 3. So 3 over 16 these are total favorable events. Not favorable, these are total possible events, all events, because we select 3 students from 16, all of them. We don't care here if it's favorable or not, but these are total events. And here we divide 72 by result of 3 over 16. So again, we need to substitute it in the formula of combinations. So we write 16 is the bigger number, rated on top is n, 16 factorial divided by 3 factorial, and here we write n minus k, which n is 16 minus 3 factorial. So this time we're not gonna simplify 3 factorial with 16 factorial because this is smaller number. If we have a bigger number, we always simplify bigger number with this in the counter. So we will simplify 16 minus 3 factorial with 16. So it will look smaller. So what will it be? It's again 16 factorial. Here we have 3 factorial, and now we have 13 factorial times 13 factorial because 16 minus 3 is 13. So now we can simplify 13 factorial with 16 factorial, and what will be left? It will be like 14 times 15 times 16 divided by 3 factorial, which is 6, because 1 times 2 times 3 is 6. So now let's go to calculator and calculate it. So we have 14 times 15, 210 times 16, 3360. Now we need to divide it by 6. So we have 560. So this is 560. So you see that probability is 72 divided by 560. So here again we write 560. Because 72 are favorable events, 560 are total events. So now when you calculate it, you can simplify it further, find the greatest common factor, and you will be able to say the closest value. So let's divide 72 by 560. Okay, so 0.128. Okay, so we can say that the probability equals 0.128. It is 0.128 as a decimal. So let's try to find this common factor. 72 divided by 2 equals 36. 560 divided by 2 equals 280, I think. Yeah, 280. Then again, you could divide it by 2 by 2 by 3 and find the lowest, but we already know that this is how it is expressed. Yeah, you can continue further. I don't want to waste time on the video, but we could simplify this fraction further. So it's up to you if you want to write this probability as a decimal or as a fraction. But that's how we solve it, and this is the final answer. The probability is 0.128, that 2 out of 3 students who are randomly selected will know the area if we have 16 total students participating in the school trip. Okay, thank you. I hope you learned something from this video. Bye for now.